Morning. I think this is my 7th year doing this. So, we had some hands earlier, but more people have come in. Who's here for their first ever UK VMUG? Well, you guys are in for a treat, because you'll have never seen this before. So, if I can get this to work, why is that not working? I tested it earlier. It's my own clicker. That's one of the problems. Let's try again. No, there we go. So, those of you who've been tracking VMware, as I know you do adamantly and every day, watching lots of our stuff on the internet, will have noticed that at VMworld this year, we brought up this new vision slide, which is the same as the previous vision slides, but with a bit more on it. So we have this mantra of delivering any application to any device from any cloud, but we added a couple of little sneaky bits on here at VMworld, which people didn't realize, but the analysts did. And it was telco networks down the bottom here, which I'm not going to talk about in great detail today. But the other thing was this edge computing piece up the top, which is what I am going to talk about today. Because in these keynotes traditionally over the years, I've tried to talk to you a little bit about what we're working on next, what we're investing time and effort in now, and what we think you guys should be looking at for sort of next year, the year after that, with your own personal careers, development, planning, et cetera, et cetera. So that's really, again, what I'm going to try and do today. So this clicker really isn't working very well. There's this understanding in our industry which is completely flawed, which annoys me, and I don't know why people still do it. Someone announces new technology, and as we announce a new technology, we try and proclaim the death of a previous technology at the same time. So someone announces containers, and we tell you that virtual machines are dead, for example, which didn't really happen. And that's because IT is not like CDs. We live in a world where, you know, the CD replaced the vinyl, which didn't really, because we've still got vinyl, because apparently vinyl's cool and trendy. And then MP3s replaced CDs, et cetera, et cetera. In fact, there was mini-disc in there as well. I had a mini-disc player, which I had 2 of them, in fact. I had a mini-disc car deck thing. How embarrassing is that? It was cool at the time. You could put names in it. You know, but because one replaces another there, we assume that's what happens in IT, and it's not. What happens is it's just more crap to shove in the data center. Actually, is the reality we have. And this happens architecturally. So we talk about containers as a service. What's happening is containers are being run alongside VMs, in VMs, not as a replacement for. PaaS. PaaS is not a replacement for everything else we've done before. So not everyone's moved all their applications to Cloud Foundry, and they're not going to. There's bits that are going to run elsewhere. Now we have functions as a service, or serverless, or whatever you want to call it. Now that's not going to replace PaaS, and it's not going to replace CAS, and it's not going to replace IaaS. They're all going to exist. And in fact, the architecture that I'm now seeing in companies involves multiples of these, if not more. So a really good example that I'm using is one of our customers. They have a system of sensors, which is what I'm going to be talking about today. Those sensors, when a sensor sends a piece of information back, that's picked up by function as a service running in Amazon Lambda. That then writes back down to a SQL database running in IaaS. And then later on at night, there's a container-based application that fires up and does assessment and analysis on the data sets collected from the day, which is then accessed the next day by people using a mobile app which accesses platform as a service running on Cloud Foundry. So it's not one replaced any of the others. It's just you're going to have to understand all of these are going to have their place as you go forward. So you have at the top these provider-native platform services. Now, provider-native is things like function as a service, so Lambda or others, or Office 365. They're very fast to use, but they're sticky. Sticky is the new trendy word for lock-in, by the way. But they are. Now, people are okay with that. I'm all right with being locked into Office 365. I mean, does it really matter? Email's not exactly a differentiating activity for me. I'm not going to do better because I use a different email system to someone else. So it doesn't really matter. The same with some of the other levels at that top. When we get further down, when we're looking at PaaS or CAS, there you're trading off some of the speed, you're still very fast, for some operational stuff you have to do that you don't have to do at the top. So if you start playing containers, you've got to worry about what's in the containers and how you manage the containers and how you back them up, et cetera, which is some of the challenges today, and I'll talk about that later. So there's this risk for what we call operational drift, where you end up with a different operational model for that platform than what you're used to. And so you still get the application agility, but there is that potential. And then down the bottom is IaaS. Or CAS actually sits down here to an extent as well. But that's where you get operational consistency. And then on top of that, you can layer the other levels. And so actually, as we go forward, what you're going to be doing is not replacing any one of these with another one. You might replace part of one of these with another one. What you'll do is you'll slowly unpick your application and make sure you've got the right bit for that application running in the right place. So it might not be the best way to run your app is a massive great Oracle database with WebSphere running on top of it anymore. Splitting up the data to be stored in different forms depending on the type of data it is. Taking that WebSphere server, splitting it up into different ways of building that app intelligence and serving up web into PaaS and CAS and other ways is probably, and in fact is actually what's happening. And I'm going to go through today and talk to you about how that's happening, but how those architectural changes and those changes in how we're building applications are changing the infrastructure. And they're changing how we deploy and manage infrastructure too. Now, I apologize for the next slide sets, because it's a slide that sorry, my daughter was in 3 different productions of Beauty and the Beast last year, so I've got this in my head. I can't literally get away from it. But these next slides are literally a tale as old as time, and those of you who've been here before will recognize them. But there's new bits added on the end, as there always is, because this is an evolving story. This year, it's about getting closer to the edge, as Yes covered in their seminal 1973 album. To be honest, it's a crap album. Literally, I'm a big prog rock fan, as some of you may know, but I really don't like this album. But the first song for me actually was quite good if you ever listen to it. Don't, but if you do. It's massively chaotic at the start, but then starts to get a little bit of semblance of sense as it gets a bit later through the song, I think, as the drugs start to wear off in Rick Wakeman's head. And that, to me, is kind of indicative of what's going on in the edge computing world at the moment. We're still at that chaotic space. We're still at the people popping up saying, I'm doing edge, this is edge, that's what's going on. And you'll see it flesh out over the next 2 or 3 years as we start to settle down into that latter part of the track. So, here's the slide you all know. And this, yet again, is the best way I've come up with yet of explaining how our stuff works and what we're building at VMware. You take the concept of a RAID controller, where we get a bunch of disks, make them look like one big disk, and then you deliver that disk as a service. Swap out the pictures of disks for data centers, and swap out the picture of RAID controller for operating system for data centers or software-defined data center, and that's essentially what we're building at VMware. Now, you see in their individual sense things like NSX and vSAN and all these other bits of technology, but they are part of a bigger plan. They're not just bits of software we bought because we thought it'd be fun to sell that. In some cases, it isn't fun to sell that. So what we're doing here is trying to work out how we can get it to the point where these applications that sit on the top in their containers, and yes, we've called them containers for years internally, just we never called them containers externally because no one would understand. But the reason we call them containers is the guy that worked on this with me and a few others at the start is a guy called Paul Strong, who actually invented containers on Solaris as a concept. So he was forceful in his operating system fundamentals that we called them containers and not VMs, which was hard at a company called VMware at the time. So the idea was that we should be able to move these freely from one place to another. And the freely from one place to another was the big challenge. So we had vMotion. We all know about vMotion. vMotion was fantastic. And I always loved the fact that when vMotion was announced back in sort of over 10 years ago now, most people looked at vMotion and went, nice toy. You know, like, why would anyone ever risk moving a production application live from one server to another? Are you mad? We'd never do that. And we still do have a customer that has a paper-based approval system for vMotion. I'm not kidding. But now vMotion has become something that is so normal, natural in what you do in managing virtual machines that it's not seen as magic anymore, it's just part of what you do. The problem we had, though, was when you vMotion from one data center to another, as we introduced, and now with long-distance vMotion, you can go even further, we bumped into a whole bunch of other people that caused us problems. Networking people got upset because you were going to try and change IP addresses and try and have to reconfigure firewalls and all this other wonderful stuff that you don't really want to do. Or they don't want to do, actually, is the point. It's not up to you. So you had to go through this process and pain. Then the second piece was the fact that you had storage problems, because storage wasn't everywhere, and if you moved the virtual machine from one place to another, the storage didn't come with it. So we had to invent something called vSAN. So NSX and vSAN were the networking and operating and storage parts of our operating system. They weren't something we did to go and attack the network market or the storage market. So if you now see instead what we're looking at building is a layer of software that you pour across multiple physical servers, then ultimately multiple data centers, and we need to put stuff in that layer that means that the VMs or the containers that we put on top of that are completely disassociated with anything physical and can freely move around, you start to get the idea of what we're building. And that's why I call it an operating system for data centers, not just a software-defined data center. The software-defined data center is kind of not quite the right way of describing it. But if you think of it as that operating system, it starts to make sense. It does to me anyway. It also helps us when we try to do the ultimate goal, which is that we should be able to lose a data center and carry on. Losing a data center should be as exciting as losing a disk in a RAID array in terms of your response as an organization. And we're not there yet. And I don't know if and when we will get there, but it's a goal that we're aiming for, is to put this layer in place as much. Now, you can get there today, but it's not quite as simple as just drop the VM on. There's a whole bunch of stuff you have to do with FT and other things to make it work, but it can work. So the next piece on from this was to swap the pictures of data centers. Oh, sorry, no, actually, the next piece on from this was to understand that there's different types of workload come along. So Docker comes along, or containers. And an interesting comment now is people have stopped talking about Docker now and just start talking about containers, which is, an interesting tipping point for me is that containers is what people reference. They don't reference, oh, I'm doing Docker. They say, I'm doing containers. So a whole new category of containers has been defined. And people are now playing with putting applications in containers. And I'm going to do a section at the end of this to talk to you specifically about what's going on with containers and what we're doing in that space and give you an idea of the things you should be looking at or focusing on. But if you swap the pictures of data centers for pictures of clouds, you then get to what we call VMware MultiCloud. And VMware MultiCloud is literally where we're trying to build this operating system for clouds. Now, when you're trying to build an operating system for clouds, oh, look at that. I've got the pop-up for the this is a keyboard, go away thing. Here we go. Right. When you're trying to swap in an operating system that goes across multiple clouds, there's a really big problem here. This picture only makes sense if you get all the clouds to run your operating system. If they don't, it's kind of pointless. And if people have been asking what's happened with VMware, why is VMware suddenly so successful? Why is our stock price so high? Why is everyone raving about us? It's because they finally worked out we're doing this. They've worked out that we've got 4,500 cloud providers worldwide running our operating system. People like OVH, obviously, but then you've got Vodafone and Atos and Deutsche Telekom and all these other kind of UK Cloud, et cetera, all running our operating system to operate their public cloud. Then IBM announced that it's what they're going to use to run their public cloud. Then we announced VMware Cloud on Amazon, where you can go and run your VMs natively on a native stack in Amazon and access vSAN and NSX, et cetera, natively in Amazon. And so now there's only a couple of clouds that aren't running our stack. And I'll talk a little bit more about some of them later on. But what's happening is that we're not all going to the cloud. Now, if you'd gone back 10 years, we were all told that by 2015, everything will be in the public cloud. Remember that? By 2015, everything will be in the public cloud. I don't know about you, but it hasn't happened as far as where I look. It's not anywhere like close. Because cloud is just another place to do stuff. It's not the only place to do stuff, and that's the important thing to realize here. People aren't realizing that moving all my stuff to the public cloud is the answer to everything. It's the answer to some things that we're doing in some places for our business. And what actually people refer to as the hybrid cloud, or we call multi-cloud, is the fact that actually people are now running stuff both in their data centers and in the cloud, and that is their strategy going forward. And there's multiple reasons why they might want to run stuff in their own data centers. Legal reasons to do with data or privacy or security. There might be reasons to do with operational reasons. There might be reasons in terms of DR. There's all manner of reasons why people want to run their own kit still and will continue to do so. But what's happened recently is the ultimate swinging of the pendulum again, and we used this at VMworld in Pat's keynote. We started off with mainframes, where everything was centralized. Then through the PC era, everything was decentralized, and the world tried to put their arms around it and pull it back in again with the invention of Ethernet and Intel Lamdesk and other things as we try to make the PCs unusable yet connected. And then we've now gone to cloud, where we think we're all centralizing back into cloud again. What's happening is we're going back out again because the cloud isn't everywhere we need it to be, and it's not doing everything we want it to. So now we're seeing that we need to get this operating system for clouds to not only run in the cloud for the cloud providers, not only in your data centers, but also at the edge. Because people are starting to want this level of service, this operating system to run right out in their branches. So a good example here is if you go to most retailers and go into one of their branches and go into the back office, which you probably would get told off if you tried to do, but give it a go. If you go into that back office, those of you who've worked in these environments that I have in the 90s will know, in the back office there'll be like a 22U rack, maybe a 42U rack if it's a bigger branch. Now in that is like a little museum of IT, okay? There'll be some weird WAN and LAN equipment, half of which you won't recognize. It'll be like a 1602 from 1996 in there, okay? And there'll be all this weird stuff, and then underneath that, there'll probably be a couple of x86 boxes. One of them might even be a tower PC with Compaq written on it. And then underneath that, there'll be various bits of EPOS-specific equipment. And then underneath that, there'll maybe be a new thing they put in because they're trying beacons and Bluetooth and stuff in the store. And it's all held together with this nasty mix of spaghetti string or Cat5 on the back end, and that's it. Now, the problem is if you're a retailer, that's expensive to maintain and manage. And so if we can simplify that in some way, that's what we're looking to do. How do you push and get almost like a VX rail right out to the edge? So when we look at edge and cloud-to-edge infrastructure, it tends to vary from up the very top, and we've got deep learning to real-time in terms of speed over there, but at the very top is cloud and developer services, stuff you'd run either in a public cloud or in a very large data center. Then what we call core, which would be your private data center. We're still talking about these terms in the industry, and it's not decided yet what's going to be called what. We're using core because telcos like the word core, and they think they know what that means. We don't know either. And then as you come down to the edge, things get smaller to nano data centers and gateways. So what are nano centers and gateways? Well, nano centers and gateways are a response to the fact that the Internet of Things is actually here. It's no longer stuff that people are just talking about. There's all manner of stats you can get if you look across the Internet of 50 billion things will be connected, and there's all these wonderful things happening, and the challenges are around security and management. But in effect, the biggest problem we have is that the Internet and the applications on it are built the wrong way round for Internet of Things. Everything in the Internet, well, most applications in the Internet, most infrastructure in the Internet is built around you take a funny video of your cat, you upload the funny video of your cat to YouTube, and then millions of people watch the funny video of your cat. Okay? Should have another slide here that just says profit at that point as well. But that apparently is what the Internet's built for. And all this stuff with CDNs, et cetera, is all around this distribution model where it's download more than upload. IoT is completely the other way around. IoT is millions of sensors sending stuff up to a central core, and then you pulling one or two results or a dashboard down or an alert. And we just don't have the infrastructure built to do that. And so the industry now is trying to work out how you integrate IoT and the application constructs required for IoT into a world that's invented for sharing cat videos. Now, IoT is a massive opportunity. There's no doubt about that. You go and talk to anyone, it's all about, I can increase productivity by connecting people and things, and I can improve my business processes, and we can be faster, blah, blah, yada, 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 right? But when we get down to it, and we've been doing some real IoT projects with real customers, you forget there's the of things bit of Internet of Things. We tend to think about the Internet bit and the application bit. We don't think about the of things bit. When you go and meet the of things people are very different to you and I. We're IT people. They're of things people. Now, what does an of things person look like? Well, an of things person is someone who's in the business that traditionally has worked with a vendor that sells them very specific technology to do what they want to do. They're focused on lowering cost, and typically quite a lot of what they're doing is very, very expensive. The of things technology they have for monitoring their planes, their oil rigs, their industrial systems is highly specialized. And also, it's there because it's a high-risk activity. Some of these things, if you get them wrong, people die. And yet you, the guys that gave them an XP desktop, are now coming to them and telling them you want to manage these things? That's where the problem starts. Because they don't trust IT to come and manage their control systems, their industrial control systems that have developed over the years to be very, very strong. Now, it is happening. One of the key leading companies in this space is Eurotech. And the data center is coming into the factory. But it's coming into the factory in multiple ways. It's coming to the factory by looking at the sensors. But more importantly, it's coming to the factory by we're pushing hardware into the factories to deal with those sensors and to pull the data off those sensors and then aggregate that data. Hospitals is a brilliant one. I've been doing a lot of work recently with some medical software providers and hospitals and talking to the leaders in this space. One of the things I didn't realize is the average medical professional in the Western world spends 1 hour a day looking for stuff. Literally stuff they can't find they've lost. They waste an hour of their productivity every day looking for stuff. A large amount of the stuff they're looking for is patience. And I'm not kidding. I mean, you hear about it on the news all the time. My grandma was left in a lift and all that kind of stuff. It happens every day. And so one of the key challenges that's facing doctors and nurses right now in hospitals is patient tracking systems. Finding a way that I can say this patient is here right now in this space and then tie that patient to that bed. And, you know, I mean, like, you guys have tried, not tie them physically. That's very wrong, okay? I'll never do that again. Now, no, if you've all tried the ultimate, you know, the change management database. You've all tried this, right, in your data centers. You know it never works, right? Yeah, we've got a change management database. Yeah, well, it's kind of, we bought one. No one really uses it, but it's over there. And when the auditors turn up, we tell them we use it, right? Now, that doesn't really matter that much in a data center, but a change management database in a hospital is quite important, especially when you put more stuff in. So again, we're looking at ways as how you can track this stuff. And kit as well. There's an awful lot of kit that goes walkies from hospitals. And now you're seeing people put increasingly large amounts of compute power into vehicles, not just the sensors in vehicles, which we've had for years with CAN buses and all that other kind of stuff, but the amount of compute power that's going in to collect that and talk centrally. We're doing some very, very key work at VMware with some large technology providers and some large car manufacturers about how we can help them be the management platform for their cars of the future. Because these guys are looking to do software updates live to fix problems that happen in the machines. I mean, it's, as a small journey, one of my colleagues here has got a loan car today because his car has gone into the garage for a software update, which I find is a joke because my car updates its software over the internet, over the web, so I don't take mine in for software updates. But hey, he drives an old-fashioned car. It's a Porsche. But to be fair, that's the way things are going. People are updating stuff over the internet. So this is something that's very, very serious to manage because obviously if this gets hacked, it's headline news, as you all know. So previous IT practices are now being pushed out to the edge. And if we don't get them right, there's going to be some really big screw-ups. Last Tuesday, I was presenting to the European Parliament to a bunch of MEPs on best practices for cyber hygiene. I was actually repeating almost a session that Ray O'Farrell had given to the House of Representatives, my boss in the United States, on the same deal, about things, teaching them about basic concepts that they don't understand that they should be putting into legislation. Things like patching, making sure that there's a patching ability for these things, because patching is quite important. Making sure they're using two-factor authentication for admin, starting with least privilege. Things like that. Basic stuff that you or I would assume is normal, but is not for these people because they're not used to playing in that space. The volume of data that's being pulled off is ludicrous. I mean, we work, this is Boeing 787. They create about 0.5 terabyte of data per flight. We do work with them, Boeing and Pivotal, et cetera, on doing that. I have a manufacturing company in Germany. They have a factory, and that factory generates a petabyte of data a day. And they don't store it all. They throw most of it away, obviously, but they've got to deal with this flow of it. And I was asked, I gave this presentation, or a similar version of this presentation, recently, and someone in one of the audience questions was, what's different to last time? So if you're talking about pushing all these edge devices out, et cetera, why is it different now? Well, the reason is because the network is rubbish, is the short answer. And you only have to look at your mobile phone to think about that. I've got a mobile phone coming next week which has a 256 gig of storage in it. I mean, that's 1/4 of a terabyte of storage in a phone. Why would you need that? Also, incredibly high levels of processing in the phone. You know, ARM launched their 64-bit processing A8 in phones first before they launched them in data centers. Why is that? It's because the network that those phones are connected to is not very good. It's inconsistent, and when it is up, it's not necessarily that fast. So you have to move a lot of processing to the edge. And that's exactly what's happening now in control systems and application architectures and with our customers. Well, another good reason to move stuff to the edge is I don't like to wait. I have Alexa at home, as some of you probably do as well. I don't have it on all the time because I don't necessarily trust it completely, but I do have Alexa at home. And I have Philips Hue lighting and a bunch of other things. Philips Hue lighting is actually very good. Philips Hue lighting is a good story of how they moved to containers to increase their response times. But the challenge I have is when I say turn off the kitchen light, because I then have to wait whilst Alexa listens to what I've said, sends what I've said up to the central Amazon servers, transcribes it from being speech to being text or whatever it is, does some natural language stuff against that, then works out it's got to talk to the Hue API to blah, 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 blah. 5 to 7 seconds later, my kitchen lights switch off. I know you're thinking, yeah, first world problem, Joe, shut up. Right? That's all great, but that's not a first world problem when I'm driving my car on autopilot and a car pulls out in front of me. I don't want to have to wait 7 seconds for someone to talk to a central server. I need local processing to do that. And those local processing examples are going to increase as we go through. So IT, our IT processes is now meeting with OT, the of things people. And we're going to have to work together to work out how we provide the best service to them whilst meeting the requirements they have around reliability and performance and security that they're used to from their traditional control system people. We are very good in IT at dealing with breaches, scalability, and data. Or are we? No. And that's what they're scared of. So we need to increase our ability to deal with security breaches, to deal with scalability of our platforms, to deal with large amounts of data if we're going to have to deal with Internet of Things. And so the people that win in the future are the people that start to learn now how to build massive scale systems to deal with large amounts of data that are very secure, because that's what you're going to need to understand in an architecture perspective from both a networking and application if you are going to deal in this world where IT and OT meet. Now, when IT and OT meet, you're going to actually define some lines. You're going to define lines where who looks after control and who looks after content. And ultimately, when you talk to someone about Internet of Things and you hear marketing about Internet of Things from any other company, it tends to be about the content side of things. It's all about, oh, look at all this data I can collect. Oh, look, I can do predictive maintenance on my aeroplane. Oh, look, blah, blah, look at the analysis I can do. Look at all this data I'm collecting. What they don't talk about is this bit on the left, which we can bring them from IT, which we're really good at, which is the ability to build and manage infrastructure, to set up new sensors, to onboard those sensors, to manage those sensors, to monitor those sensors, to secure those sensors. Because most of the breaches that have happened recently are down to people not doing those things. You know, one of the ones recently where someone took over a whole bunch of unsecured IP cameras and used them as a botnet. Perfectly reasonable. You know, why would you bother to patch your IP camera? No one bothers patching cameras. And so we have to bring these disciplines out to this land. Let me just get to the next slide here. Now, the other challenge is that it becomes a very, very big problem in terms of scale, because you're looking at millions of devices, all trying to talk back to this central data center and cloud. Now, remember I told you that we can't do that because the internet's not built for that, applications aren't built for that, networking's not built for that. So what we're doing now, and we're seeing, is people bringing out edge gateways. Now, edge gateways is something that sits, like I showed you earlier, in the factory, in the hospital, and talks to the sensors from the center. And so these have aerials on them because these are the things that are talking Zigbee or Z-Wave or other low, Bluetooth low energy or whatever that you actually talk to at the very edge. So they're the people that translate from the IP networking you're playing with into out talking to those sensors. One really good example of some of the cool stuff you can do with sensors is strain gauges, which doesn't sound very cool at all. But those of you who did physics at school remember strain gauges, right? It's the little sort of metal thing you stick on something, and there's the thing that it's stuck to stretches, then its resistance changes, and you can tell that the thing's under stress. Now, if you ask a guy who builds bridges or a woman who's an architect for buildings, they'll tell you they'd love to have real-time strain information from multiple points across the structure. It'd be fantastic for them to help in maintenance and ongoing management of that box or that building or that bridge. But it's it's impossible to do until now. Someone has invented, and I was looking at this a year ago actually, they came and brought it to our internal conference. It's a strain gauge that contains Bluetooth low energy chip and energy harvesting. The energy harvesting is the really cool bit, because this thing doesn't have a power supply. What it does is it gathers energy from Wi-Fi and any other RF that's flying around, and slowly but surely saves it into a tiny little battery, or capacitor essentially. And then eventually, when it's got just enough that it needs, it will wake up, take a reading, send that reading over Bluetooth LE, then shut down for the next 5, 6, 8 weeks, or however long it is until it gets enough to do the next reading. And so these, instead of strain gauges you go out and fit, what the plan with these is, that they're doing in a couple of buildings, is you sprinkle these in the concrete mix. As you're making the building, you're sprinkling thousands of these things into the concrete mix. And so you've then got the whole building talks to you. And what you then need to do is put edge gateways up to listen to all of these things talking. Now you go to yourself, well, you don't know which one's where, so how, what is it? The whole point is you don't need to. What you do is you baseline them. You build the building and you go, okay, fine, that one always says 7. And then a year later when it suddenly says 14, you're like, okay, something's up. This thing said 7 for a year, now it's saying 14. Right, let's go and work out which edge gateway it's on, work out where it is, and we'll find out what's going on in that spot. That's the kind of use case that we're looking at here for these edge gateways and others. It might be these are the things that track the RFID tag that you stick on a patient, except you can't stick an RFID tag on a patient because you put them in an MRI scanner and it blows up. So how do you tag patients? And that's something else we're looking at as well. So it's a really exciting area of the industry right now as we look at how you deal with these edge gateways. And so you end up building out edge infrastructure. And the edge infrastructure is these edge gateways, which are these points where you're talking between these sensors and you're talking back to the IP network. But then there's processing that has to be done. And the processing is done either locally or it's done one step back. So this IoT architecture, as we put it together, splits the control and the data planes into two separate things. So the content plane that you all know of and you'll all understand very quickly is you have all these connected data devices, they create data. That data goes back to the edge system and that's pushing the data back into maybe a cloud where it's done processing and analytics, and then someone over here gets it back in their application. But underneath that is what we're building at VMware, is the control plane for the infrastructure. We're building the piece that makes sure that the operating system and the networking and the security for all of those connected devices is patched and secure and managed. Think about it. If I'd had NSX capability on all of those cameras that were hacked, and they were all in their own individual microsegment, we wouldn't have had the problem that we had. You can do that using NSX and Internet of Things. Then the edge system again, we worry about operating system network and security there. Now at this point, there's a piece of technology, an open source piece of technology called Lyota, which has nothing to do with the actor. It stands for Little Internet of Things Agent. It's open source, it's written in Python, go play with it, but it'll run on practically anything. And that's the thing that will sit there and say, okay, fine, I'm going to give you, Mr. Builder of Things, the platform to go out and push out updates to all of your edge devices and make sure they're synchronized and patched and secure. And then, because we're using NSX out to this point, I can give you maybe an encrypted data path back to Pulse IoT Center. Now, Pulse IoT Center is our management plane, it's basically VR Ops and some other stuff, that allows you to then check and say, are all my connected devices up? Are they all alive? When were they last patched? When were they last updated? That can then feed back to the OT user, the of things guy, to make sure that they know that everything is in the way they want it to be, and the IT user who's managing and maintaining this control plane. So there is a really different world coming as you start to have to push the infrastructure that you've built further and further to the edge. Because you're going to have to manage these edge systems as IT. So taking control of the edge going forward is going to be very important. In fact, edge mastery is going to be a competitive advantage for companies. Speed and operational cost reduction at the edge is going to be massive for retailers, for example. So when we talk about edge computing at VMware, we talk about the use of data center class hardware and software installed geographically local to the primary source of data. And there's reasons, or data or application consumption, should I say. There's reasons why you do this. First is latency, as I've talked about before. But it's not latency. It's response time. And this is different. If you go and talk to network people, they'll talk about latency. Because that's what latency, that's what network people understand. If I'm an end user, I don't care about network latency. I care about response time. I care about how long it takes for the network and the application together to come back to me to do something. And so it's all very well and good having a fast network, but if the application components are back in a cloud somewhere, you're going to have a slow response time. So that's why you need to start moving the application components to being closer to the edge. At the same time, data analytics is just about data quality flows and data quantity. Let's start filtering stuff down so we're not sending everything back over the internet. We send just the bits we need. Maybe there's machine learning and artificial intelligence going on at the edge to help with that. Augmented reality is really important. A lot of the augmented reality relies on very HD or better quality video and then integrating what you're doing with that. Microsoft talked about mixed reality, one of the quiz questions last night. If you're playing with augmented reality, you know that if the processing for what's going on in providing that augmented reality vision in your device or phone or screen is being done several thousand miles away, it's not going to be a particularly wonderful experience. So you need the processing to be done closer and closer to where you're consuming the augmented reality. So again, we're seeing more and more compute be pushed out towards the edge, towards where it's being consumed, towards where it's being used. So there's various options. And cloud, core, and edge that I talked about before, again, are terms that in the office of the CTO at VMware, we're still playing with, we're still defining, but this is how we see it at the moment. Cloud over there is the richest set of service offerings, developer velocity, unlimited capacity, essentially, massive breadth of services, but the response time is greater than a second. So when you're doing your application architecture, you have to choose to put the things that you don't care about too much in terms of speed, maybe, right up in the big cloud. Then next is core, which is your local data centers or smaller data centers. This is where you might run some of the more advanced data analytics. You might run functions as a service. The scale ranges from a rack mount server, such as a VxRail, up to multiple rack mount servers or VxRack. There you're talking about response time of less than a second at the moment. Again, these are numbers that we're still playing with. Edge is where you're getting really close to where the action's happening. This is where they're much, much smaller form factors, those IoT gateways I saw. And the data collection you're doing, there's limited processing maybe, there's some basic data analytics running, and functions as a service as well. But you've got much faster response time. And again, application response time. Remember that, guys. It's not just network response time. It's how fast we're responding to what I need to do in the app. So to do this, there's a couple of different hardware form factors we're discussing right now at VMware. One is the micro data center, and one is the nano data center. The micro data center you can look at is sort of one to several rack mount servers. And that's running tens to thousands of VMs. Fully integrated, full vCloud Foundation, everything you'd expect from that. Over here is the nano data center. This is a much smaller form factor. For this, you can imagine maybe a couple of Intel NUCs stuck together with some SSDs attached to them. That's the size of thing I'm talking about down here. Kind of the stuff that probably some of you run for your home lab. Running less than 100 VMs. Now, I'm saying 100 VMs. It's probably not going to run 100 SQL servers, right? But when you're running 100 VMs, it might be that 60 of those are container-based, and 15 of them are doing something else, and a couple of VDI desktops. And we're working on that with a project called Nano Edge, which the guy who actually owns that project globally is sat in the front here, a guy called Simon Richardson. So if you want to talk more about Nano Edge and what we're doing around that, he's one of our C2 ambassadors. He'll tell you about what's going on there. And if you are interested in that or think you might be something you'd be looking to play with as we go into looking at that form factors going forward, I'm sure he'd love to talk to you. But this ultimately is where you see stuff coming together. So now, you saw we announced something called VeloCloud acquisition 2 weeks ago, right? So VeloCloud do what's managed SD-WAN. So They ship you a box which has an MPLS and an internet socket on the back of it and a switch, basically, and you just plug it in and everything else is configured remotely. Now imagine if, instead of sending you that box, I sent you a box that had an MPLS and an internet connection on the back of it and also had inside it 2.5 nodes running full vSAN, NSX, and ESX vSphere with maybe a very small version of vCloud Foundation that allows you to run a few machines, and that's what you can put into every single branch. That's what we're talking about. So rather than having to put all that big 22U rack of mess together, you get the modem or the ADSL or whatever it is from the local internet provider that you've got, plug that into this box, off you go. Do what you want to do. Remotely manage it, remotely update it, maybe even buy it as a service. Maybe even not own the hardware. So all the way through, the thread through all of this is consistent infrastructure. Globally consistent infrastructure. All the way to the edge. Because you've now got the same platform, the same operating system for data centers, operating system for clouds, operating system for the edge, running all the way from the data center all the way to the edge. Now what that means is you end up with globally consistent operations. Consistent tooling, telemetry, everything. From the center to the edge will end up being the same platform. You don't have to learn something else to go and use that edge bit. We make it easier for you. And we're doing that with our private cloud tooling and extending that out to the public cloud. So with SDDC Manager and VMware Cloud Foundation, we're making it as easy as possible to build and run the full cloud stack on premises. With vRealize Suite, our sponsors for today, we allow you to manage both on-premises and off-premises into the public cloud. And with those 4,500 VMware Cloud Provider partners, including OVH, who are here today, and many others, we're giving you a massive choice of destinations of where to do that. And even some of these that I'm talking to are talking about how they can get closer to the edge and provide you with services closer to the edge. Now, I don't understand football. There's various rude things I could say at this moment, but I'm not going to say them. But I am educated, so therefore I don't understand football. See, I said it right. No, I don't really get football. I'm a geek. But here's a really good scenario where this all comes together in a very, very simple way. Telcos. Telcos are going through a revolution right now called NFV, which is network function or network feature virtualization, where they're just realizing that if you virtualize all that hardware stuff you've done for years, things are really good, which you guys all knew 10 years ago, but telcos are just realizing that. Now, when you virtualize these things, what you find is that that base station that you have at the bottom of a cell tower, which contains what's essentially called an RCN, a radio control node, stops being a bunch of very hardware and provider-specific hardware, with various different things like Huawei and Alcatel, et cetera, written on it, and essentially becomes a bunch of x86 servers, much as I was talking about the branch change for retail, et cetera. So now, instead of having a bunch of very specific networking equipment everywhere, you've got a massive distributed cloud because you've got a bunch of x86 servers at the base of every cell tower. This is an opportunity. Because now you can turn around to a betting company, let's just pick a betting company, your favorite betting company, and say, I happen to know that Manchester United is the only football team I know, or Manchester City are playing at home next week at Ellen Road. No, see, I get that wrong as well. So Manchester United are playing at home next week at Old Trafford. You could turn around to that betting company and say, would you like to move all your front-end web services to run in the cell tower at Old Trafford for the period of the game? So that your app is the fastest responding app. You are the best betting platform for people at the game. They're going to go yes. Now that's possible because we've got x86 running all the way to the edge. We've got an operational management platform that means it's easy to move stuff there. And maybe it's possible because they've taken their web server, which is used to be running in some massive, great, big monolithic thing, and they've split it down into multiple different components. And the bits they need are now in containers, and they can just fire those containers out to the edge. Or not even fire them. What you do is you just create containers that are appropriate at the edge for 4 hours and then kill them again. That's the kind of models that are being made possible with this. That's the kind of application infrastructure you guys are going to have to deal with as we go into the next sort of 5 years of our industry, as people start to fire up bits and pieces at the edge. A lot of the container stuff I'm hearing isn't happening in data centers. It's how can I fire a container up just there to deal with the thing I need to deal with? How can I fire up a function as a service running in a pizza van, for example? How can I fire up these things doing what I need them to do just at the edge at the right time? Providing the control plane for that, the management for that, and the infrastructure for that is going to be a big challenge. But it's a task that I think we're all up to. So what's going on with containers? Because I've mentioned it a few times, as you may have noticed through this presentation. Why people are using them? Hopefully you've got a bit of that as I've been through this talk. People are using them because they're simple. They are lightweight, and they're portable. There's trade-offs that you make, and the trade-offs are quite big in some cases, but people are using them because they're these simple, lightweight, portable things. There's still challenges. The challenges are around the fact that still we've got evolving container technologies. People aren't quite sure which horse to bet on yet. There's many different stories as to what is the best container mechanism to use right now. There's lack of production capabilities. There still is a great lack of production capabilities for containers. There's a lack of what we call day 2, which is day 0's, I'm playing with it in a lab. Ooh, isn't it fun? Day 1 is I can install it in production, which is following some scripts or paying a consultant to do it for you. Day 2 is now I've got to run it. Now I've got to worry about DR. Now I've got to worry about backing it up. Now I've got to worry about all these other different things that I don't normally have to worry about. The best thing is you get all these people to deal with containers and application development, blah, blah, blah. If you want to drop them dead, ask them how they do identity management, because none of them have an answer for any of that, but it's one of the challenges that they have in that space. So these operational tools are missing, and there's a skill set and talent shortage. We are seeing people still do it, though. There's 3 real models people are using in adopting containers. One is developing brand new applications, brand new, exciting microservices, 12-factor applications. Not a lot of that is happening, but that's what people are doing. The second is repackaging, or V2C, as I'm calling it now, which is take something that I used to run in a VM and run it in a container. Now, some people are proudly getting a Java application and putting it in a container and telling you they've done containerization, until you point out that the Java was running in a JVM anyway, which was essentially in a container as it was, so you haven't actually done anything, but never mind, well done, right? And people are using that as demos of how they're going into production, but there's a lot of repackaging, which can be quite clunky, and it's not necessarily the right way to do things, but people are putting things in containers for the operational benefits. And refactoring, which is a posh word for a rewriting. Just getting existing applications and rewriting them to run in containers. Click this one again. What we're doing at VMware is making sure that containers become first-class citizens on our operating system for data centers or operating system for clouds, on the SDDC. By bringing together technologies through all these through vSphere, NSX, vSAN, and vRealize, and supporting things like Cloud Foundry and PKS. So first is VIC, vSphere Integrated Containers. vSphere Integrated Containers sits on top of the standard VMware infrastructure, ESXi, vSAN, NSX, and allows you to run containers, one container per VM. In fact, we can now stand up a Docker engine as of version 1.2 and do multiple containers with a Docker engine per VM. Really, this is, we're seeing a lot of this where people are taking traditional applications and repackaging them into containers. Because what this allows you to do is to expose all the strong features of the NSX, of the VMware stack up through to the containers. So you can have them having NSX allocated IP addresses and microsegmentation per container, for example. You can expose vSAN or essentially vSphere storage to a container, and persistent storage and storage is a real issue. I was being interviewed by a journalist yesterday about this, and he asked me, so do you think persistent storage will ever get fixed in containers as a problem? I said, yes, it's fixed already. We've done it in VIC. Next question. That's why people are using it. The other one is PKS, which is the Pivotal Container Service. And essentially, this is the way of operationalizing Kubernetes. Now, for those of you that don't know what Kubernetes is, there's a small history lesson here. Google use containers. They have a thing called Google Container Engine, in fact, GKE, which they run on the Google Kubernetes engine, where you can go and use containers at scale in production. When Google wanted to do their own containers, they had to build an internal tool to do that. Part of it was Borg, and then on top of that was Kubernetes, which was how they were doing the, essentially, they call it scheduling, but orchestration is probably an easy way to understand it, of all of those containers. They made that open source, and then literally in the last few weeks, Kubernetes has been accepted as the de facto standard in the industry for managing containers at scale in production. Docker themselves announced they're providing support for Kubernetes at DockerCon in Copenhagen a few weeks ago, so there's kind of Kubernetes has one. And so what we're looking at is how do we provide that operational production ready at scale Kubernetes that's supported for customers to run, because they don't want to go into open source and hack it together themselves. And so again, PKS is a mainline Kubernetes distribution. It's lockstep with Google and will be lockstep with Google. So we have this constant compatibility with GKE, which is the Google Kubernetes engine. So there's a hybrid cloud play there as well, because you can build a container-based infrastructure that goes both on-premises and into Google and back again using the same infrastructure. It runs on vSphere VMware Cloud Foundation. The differentiator here is we're putting deep integration with NSXT, so there's all that NSX richness is going to be exposed up through the Kubernetes layer, and production grade, and we'll provide all the tool sets underneath for day two stuff like HA, like security, like multi-tenancy, like tools, like identity management, and all the other things that are missing generally from most implementations of containers in production. So the way that it looks in reality is you have, again, vSphere and vSAN down here, on top of that NSXT, and then on top of that a thing called Bosch. What the hell is Bosch? Bosch is what we wrote as an equivalent of Borg years ago. So Borg is the Google version. Bosch is the VMware version. Those of you who've seen 2001 might look at the words Bosch and Borg and think about HAL and IBM and maybe work out where we got the name Bosch from. And what Bosch is it was written to sit underneath Cloud Foundry as the ultimate way to make sure you have the right number of VMs spun up and configured with the right number of containers in them, because Cloud Foundry runs in containers, to support the application at all times. It's a really, really good VM to container orchestration layer. So we, with Pivotal 2 years ago, put that into the public domain, and together we've put them into a public, an open source project which brings Kubernetes and Bosch together, the same as Kubernetes and Borg, called Kubo. And so what we're really doing here is we're bringing out to market the well-established, running since 2011, 2012 in production, best way to orchestrate containers on top of a VM infrastructure, along with Kubernetes, the best way to orchestrate containers into one supported public platform. So now you get more choice. Again, someone says we want to play with containers. You go, well, how are you playing with containers? They'll surprise them because they won't even expect you to know what a container is. And they'll go, well, are you just playing with container images? Are you just repackaging existing stuff? Yeah, fine, we'll give you Vic for that. That will give you a northbound Docker API. Go for your life. Have fun. Oh, you want to go into full-scale production, and you're looking at sort of, some templates and deployments and management around a much larger scale thing. Well, that's fine, because we've got Pivotal Container Service for that, so we can give you a full-blown Kubernetes platform for you to run in production. Oh, you want to play with the PaaS? Cloud Foundry. Again, trying to make sure that on this IaaS layer, this operating system for clouds and data centers, we give you the best choice. And there's no reason going forward why any of these couldn't run at the edge. So if you put that all together, that's an awful lot to talk about in one little bit of thing that was added on during VMworld. But we added it on because those of us in the Office of the CTO have been working on this for quite a while. It's a key area of research, development, and thinking about how the way that applications are changing and the way that infrastructure is changing and where they meet together at the edge, how we can bring together a lot of value with all the stuff we've done in the data center and extending that out to the edge. And this is the difference between last time when it was with PCs. Because last time PCs was people doing anarchy and us trying to put our arms around it to bring it under control. This is us taking something that is well established as the best way to run data centers at scale and pushing that out to the edge. It's the other way round. And so with that, I hope it's given you something to think about during the day. Maybe look at some of the stuff you're talking about with some of the other sessions today and ask how maybe in your environment, if you're a retailer or you're maybe petrol stations that has, one of our retailers and petrol stations has over 40,000 petrol stations, those are the kind of things where edge is going to become really important. As more and more technology comes into those edge devices and people start doing more things at the edge, maybe they want to start putting, as I said, Bluetooth beacons in or tracking patients or other stuff as well. So we're there with the control plane and the devices. We're going to help you do it. So with that, I'll send you off to the break 1 minute. Actually, I'm on time, actually, so brilliant. Thank you very much, guys. Cheers.